Research, and that's a small company that does market research related to mobile devices and base stations and IoT devices. For example, we publish a lot of market research around IoT connectivity. We did a study last year on industrial IoT and the variety of connectivity formats that are being used and how those will converge. Just a few opening words. I mean, one of the things I wanted to point out is that, you know, the industrial IoT, I think, is one of the main focus segments. We talk about enterprise IoT. I think this is, to me, this is one of the big ones. Try to remember to talk into this, even though it's not doing anything. But for the people on the recording, they can hear me. In the forecast we published last year, we have, for 2017, we expect about 850 million IoT devices to be shipped. And out of those, about 400 million of them will be to enterprises. Roughly 130 million would be for industrial IoT, and a whole lot of those are using wires, field bus or Ethernet or something like that. So when you start boiling it down to, you know, what's really the wireless opportunity, it's in the range of 30 million or so devices per year, and that's still a significant opportunity. So this is the thing about the IoT market, is it's huge. You know, we're talking about billions of devices in all these different markets, but even when you do like fractal geometry or something, you start getting down into a very specific market like oil and gas. There are still lots of devices to be shipped, and they're expensive. I mean, in this particular market area, we have modules that are in the $800 range, maybe over $1,000 for some of the modules. So it's a multi-billion-dollar module business. And for mobile operators, there's a service opportunity. For the oil and gas companies, there's a lot of savings opportunities. And so it's a significant piece of the overall field. And that's what we're going to focus on today. So for our first presentation, our first non-presentation, I'd like to introduce DouglasHackney, who is the president of Enterprise Group Limited. And he's going to talk to us about making the Internet of Farm Things work, how to get actionable information and business value from over 2 trillion agriculture IoT and related data points in large-scale industrial farming. So welcome, Doug.
Thank you. I'm going to jump up here, and I'm going to go ahead and step through my slides because the folks that are online can see these. Thank you, Joe. So let me just toggle. Are these all on the desktop, right? Let me just toggle in here, and there you are. Okay, we'll pull this up so that the video recording and that the folks that are watching at home can follow along with the slides. And I'm just going to use the keyboard, and we'll try to do away with the remote. So what you're not going to see is a little bit about my background, the background of my company. We've been doing enterprise data and analytics solutions, big data and so on, for over 25 years now. I'm dating myself. I started when I was 8. So there's a bunch of logos on that you're not seeing on the screen here in the room, but they are seeing at home. And I just want to touch on one of those logos, which is GE. I did a lot of work for General Electric, and I want to tie in some of the comments that Paul made in the last plenary session, if you happen to be down there for that. As you saw from the level of his presentation and the overall story that they tell, it was a wonderful experience for me to work there and kind of got my PhD in business reality there. A great education, I think a great organization. And I'm going to echo some of Paul's words and his lessons learned here in our experience in IoT, industrial IoT, over the last 4 years in the agriculture vertical segment. For those of you who are contemplating going after a business offering in agriculture, and probably in several other verticals as well, the reality of IoT in agriculture is that in the past we had what was really an Internet of Services, and those of you who have been around IT and enterprise software remember all the services bus and so on. That was really the Internet of Services, and that's a voice for the software. We created a way for the software to talk to other software, for systems to talk to other systems. Now we call them APIs. That's the Internet of Services. Right now, what we're all here today to talk about and learn about is the Internet of Things. That's a voice for the machines. Where we're going in ag, and the research that my company supports and subsidizes at universities around the U.S. and around the world, is a voice for the crops. And that's where we're headed in IoT and ag, is we are going to put a sensor on every plant, or at least on a sampling, a representative sampling of the plants. We're going to give a voice to the crops. Now that, as you can imagine, is several orders of magnitude in terms of quantity of distribution larger than just the machines. So what we do right now is we collect the voice of the machines and the agriculture and of the operational systems and so on, and we create actionable value for the business out of those voices. And I'm going to tell you a little bit, very briefly, how we go about that. So the agriculture market, for those of you that are familiar with manufacturing, this is basically a roofless factory. So think it's a manufacturing business model. When we go in and we do our data modeling in ag, we start with our manufacturing data model, and then we just extend it. It's a batch process, so if any of you are familiar with like pharmaceutical batches, right? So if you're going to cook up a batch, or in brewing, right? So for those of you in home brewing or craft brewing, that's a batch process. They brew a batch of beer, right? They brew a batch of pharmaceutical products. In agriculture, you are growing a batch of crop. So it's manufacturing, it's batch manufacturing. The challenge here is you get one batch per year, right? If you're in the northern and southern hemisphere, you happen to have operations on both sides, you get 2 batches per year. Now, from us as suppliers, and for the people in the room thinking about, I'm going to throw together a business model around agriculture, the challenge of that is you got 1 revenue point per year, right? They're collecting revenue once per year. So imagine having a business model that's predicated on a really good relationship with a bank. Because the rest of the year, they're working on a credit line. And this comes into play when you're talking about go-to-market. How do I go to market? The graphic that you're not seeing here in the room, but that you are seeing at home, is all of those symbols for different weather. So there's lightning, and there's rain, and there's sun, and there's snow, and all that, right? That's because all that's coming through this where the roof used to be, right? There is no roof in ag. So it's raining down upon your assembly lines. It's pouring hail into your manufacturing facility. The wind, straight line, shear force winds are coming and blowing through your plant, right? This greatly affects not only the outcome for the company, for the manufacturing company, but also for us as a group of people that provide systems and solutions. Try turning that on. Reach over there and push the power button, David. The challenges around the agriculture IoT market, if you haven't been in this space before, the ag market has a set of particular, somewhat unique challenges. The number one challenge in ag is insularity. That is the biggest challenge in that segment. It's a characteristic of the market, and you'll just have to deal with it. If you haven't been in there yet, you will discover it when you try to go in. It's a challenge to coming into that segment if you're not one of the few handful of brands that currently dominate ag globally. The second challenge you're going to face is the channel. Think about consumer markets, right? If you think you've got a great idea for this Internet of Things device, your big challenge is not thinking up the idea. The big challenge is not designing the circuit. The big challenge is not getting it manufactured. The big challenge is go-to-market channel. How do you get the product down the channel into the hands of the customer? And it's the same thing in ag. In ag, there's this phenomenon known as the farm-gate relationship, right? If you don't own the relationship at the farm gate, at the gateway to the farm, then you're never going to sell anything to that operation. And there are a handful of people that currently own that channel relationship, that farm gate relationship. And if you're not in partnership with those channel owners, then you're going to struggle to deliver into this marketplace. Repeating the same thing over and over and expecting a different outcome is one definition of insanity. Please turn off the lights. Thank you so much. The second problem that you're going to have is trial, adoption, and retention rates. Consumer technology, people try things, they adopt things. It's easy to throw some VC money at a promising business model, get some consumers to adopt it, and boom, you can build a business around that. Everybody gets an exit, everybody wins, right? The challenge in agriculture is that Trial, you can gain trial because growers, especially small-scale growers, are willing to try everything. But unfortunately, they have no process rigor. They don't even know what a longitudinal study is. And trying to get them to ever realize or be able to attribute results to any one given cause is very challenging. Larger operations, not so much, but it's still a reality of the marketplace. Adoption and retention is a real struggle in agriculture. So for young startups that go in with traditional VC money, just like traditional VC funding, if that's the kind of model you're in your head you're thinking about, that can be extremely problematic. It's like clean tech take two for the traditional Standard Valley VC funding model. This isn't gonna turn out well, right? So a couple of years ago, especially, the regular Valley VC guys were just throwing money at the ag. Ag was the hot thing that year, that 2-year period. Most of those they aren't gonna be happy endings. It's not gonna be a good story. Strategic money is good. If you want to do a startup and you can get some strategic VC money out of one of the existing brands in ag, or somebody that understands this may take 10 or 15 years, that can work in terms of a funding model. The last thing is perceived value. Right now in ag, it's moribund. A few years ago, there was $8 a bushel corn, and using a U.S. volumetric measure, and now it's $3 corn. So that means that everybody has stopped spending money. Nobody's buying any tractors. Nobody's buying anything. They're cutting back on fertilizer. They're cutting back on herbicides. Everybody is cutting back, just trying to find a way to make money. Because imagine being in a business, if you're a grower right now in the U.S. and North America, every acre you plant, you know you're going to lose money on this year. Think about that. You're going to go out and put millions and millions and millions of dollars in the ground in seed and herbicide and fertilizer, and you know for a fact that unless all of a sudden some region of the world, like South America, just has a complete failure, you're going to lose money. So it's a period. Ag is very cyclical, right? Right now is a down cycle. Now, what works is that it's a great time for you to get started, especially if you're from a large enterprise. Now is a great time to get started because that curve is going to come back up, and it's going to take you a few years anyway, right? You got to build a solution, you got to take it to market, you got to build those channel relationships. If you start now, in a few years when things come back up and people are buying things again, you'll win. Don't wait to get started. Tech challenges. Most of the people in the room here are tech people. Here's the technical challenges of ag. Number one, very spotty cell coverage and absolutely embryonic LP-WAN implementations, right? I've had the good fortune to travel a lot around the world. I've been in the middle of nowhere in Africa, pulled out my flip phone, my little feature phone, had great coverage. Come back to the US, drive out 20 miles away from a city into a rural area, zero coverage. Rural America is like a fourth world implementation when it comes to cell coverage today. So don't count on anything. All these great messages that you hear downstairs about 5G and zero latency and da-da-da-da-da-da-da, that's great if you're building a solution for right here in downtown Austin, right? You go 30 miles from here, zero, okay? Don't count on coverage. What's that mean? That means you've got to be able to buffer data for weeks. We've got equipment that's out in no coverage for weeks at a time, storing hundreds of megabytes an hour, right? And then you got to shove that up to the cloud when you get back in coverage. Second tech challenge, heterogeneous data sources, types, and frequencies. And I don't mean just RF frequencies like we normally think about in tech, but think about periods, right? The different periods when you're going to receive this data. Some of it's going to have requirements around latency that are diametrically opposed to this other data point that you have to deal with, this other data source. Ag is marked by a tremendous number of proprietary data silos. There's no semantic consensus recently, right? So in the last year, they've come out and tried to do some semantic work. In the last year, they've come out and tried to do some standardized data modeling work, right? But prior to that, no. Third, and very important, geospatial user experience. Everything must be geospatially tagged. That means anything you do on IoT and ag has to be geospatially located, or its value is very low. How much battery power does it take to run a GPS? Right, a module. And lastly, context equals value. If you don't put your IoT data in context, remember the rain, remember the factory with no roof, If you don't tag every data point in a way in which you can mix it into the context of when that happened and how it happened, the value is extremely low. If I've got soil moisture level, great, but if I don't have the context for that, did it rain? Did it not rain? Did the pivot run? Did it not run? What was the tillage practice over that field? How long ago was that plowed? You have to have the context. So, value prerequisites, if you're going to create a solution, we capture and analyze about 15 million data points per acre per year. That's the kind of volume you have to be thinking about. 15 million data points per acre per year. You have to have unlimited geospatially referenced data layers. You need near real-time heterogeneous data integration and analytics. So I can see 2 or 3 minute old data from all of our operations that we run for our customers on my phone anywhere. And lastly, multivariate analytics, which is something that ag has never had before. They've really only been able to look at one variable at a time. But you have to be able to give them a multivariate analytical solution. So if you want to see an example of this, our system is called fact-based farming, factbasedfarming.com. So if you want to see how it looks in implementation, how it looks to what one of those systems really looks like that combines Internet of Things data with other data that's valuable for a grower in ag, go out to that site and you'll see some examples of what all that looks like in action, in reality. So thanks for your time. I ran over, so I probably don't. Catch me outside in the hallway and good questions.
I have one question for you, Doug, as we
Yes, sir.
just break for Q&A briefly. You mentioned that some of the devices store data for weeks, but other devices you have real-time access to the data. So how do you see those different scenarios, and where does each type play?
The key thing in building in agriculture, and I think in other, think of other like oil and gas, right? Oil and gas and ag share a lot of characteristics. They're both like battlefield conditions without the bullets, and they have remote locations where you cannot be guaranteed of even a gateway working. But you have data requirements for real-time, near real-time, latency. I don't care if I see it for a week. I need this within 2 minutes, that kind of data, right? So what you have to design for is resiliency and recovery. I'm in the business of turning technology into real-world solutions. I give keynotes, so I can't bang on the keynote speakers downstairs. I've done that too. But I have to connect those platitudes with reality, right? And out there in reality, when you're building real IoT solutions on the ground for real customers, you have to design an architecture that can recover from the inevitable failure, because in the real world, things break. So part of that resiliency, Joe, is that if you do lose coverage, when you gain coverage, it recovers seamlessly, smoothly, right? So it doesn't matter if your servers crash or the module goes down or you get a bad over-the-air update, right? Everything has to be able to recover seamlessly.
Okay, super. Any other questions for Doug?
Yes, sir.
Just quick, you talked about cropping and in the field work. Have you looked at anything with livestock at all?
We do not currently provide a livestock solution. We engineered a solution for a potential customer, for a prospect. Livestock IoT is very mature, dairy, and especially in dairy, but also in beef production, right? So we've done a lot of work around RFID, so that's a technology that's known to us, right? So we know how to capture that data and integrate it in real time as well. That's a particularly mature market segment of ag, I would say, around IoT.
What kinds of sensors are you thinking about for giving that plant a voice?
The question was, what kind of sensors are we thinking about for giving the plants a voice? I think that we're all, waiting for the ubiquitous 5G that's going to save the world. Right? That was a joke. But low power wide area network, obviously, right? There is RFID involved in this too, right? So.
All right. Thanks very much, Doug.
Joe, sorry.
Oh, okay.
You're very welcome. Thank you. Thank you for the opportunity.